Hello, welcome to another session of which we are going to look at differentiating by product rule. The other time we are looking at the differentiation by the general rule, but today we are going to look at the product rule. So before we go any further looking at the formula and the other things, we are going to look at some of the standard derivatives. Okay, so what are some of these standard derivative? So the first one we are saying, when you have y is equal to ax to the power n, when you differentiate this one, its derivative is na x to the power n minus 1. Okay, that's the first one. Then we are also saying when you have the second one, it is y is equal to sine ax. The derivative of sine ax is equal to be a cos ax. Okay. The third one, when you have y is equal to cos ax, then its derivative is going to be what? Negative a sine ax. Okay. 4. When you have y is equal to ln ax, these are natural logs. So the derivative of this, it is going to be 1 over x. And the last one, the fifth one, when you have y is equal to exponential the power x, let me use x, ax, then its derivative we are going to have a e to the power a x. Okay, so these are some of the standard derivatives that we are going to be using as we'll be going further on. So whenever you see you have sine ax, that means its derivative, when you differentiate it, you're going to have a cos ax. When you have a cos, you're going to have the sine, the negative a sine ax. This a is representing a coefficient. Okay, so let's now go straight into differentiating using the product rule. The first thing that we are going to do is to write the formula, and the formula of a product rule is dy over dx is equal to v du over dx plus u dv over dx. That's the formula that we are going to be using when finding, when differentiating using this product rule. Okay, so let's look at the first example. Sometimes again, if you're using the y prime, that means you're going to have v, then u prime plus u v prime. In case maybe you come across this formula, you might think it's different from this, but they are not different, they are just the same. Okay, so let's look at the examples. We'll start with the first example here. So the first example, differentiate y is equal to 3x squared sine 2x. So if we look at this type of equation, the word itself product, that means you've brought two things together, you you multiply them. So we have 3x squared. We have also sine 2x. So we have two things here. We have this and we have that. So the first one is going to be our u. The second one is going to be our v. So we say let u be equal to 3x squared and v be equal to sine 2x. Okay, so now we are going to find the u prime here, which is going to be, remember the first rule where we said when you have ax to the power n, its derivative, it is nax to the power n minus 1. So this power is going to multiply with 3, you're going to have 6x. Then you subtract 1 there, you're going to remain with 1, which is just 6x. Then you have v prime is equal to, when you differentiate this one, its derivative is what? 2 cos 2x. Okay, so now we are going to bring down our formula. Y prime is equal to v u prime plus c u v prime. So y prime is equal to, what is v? Our v is sine 2x multiplied by v prime, which is u prime, which is 6x. Here there's a plus. Plus we have u, our u it is 3x squared multiplied by our v prime is cos 2x. Then we expand here. Y prime is equal to 6x sine 2x plus, when you multiply here also you're going to have 3x squared cos what? 2x. Okay, so you can factorize what is common here. So y prime is equal to, you have 3x open brackets, here you remain with the 2 sorry, our v prime okay, so we are going to have y prime is equal to, what is our v? Our v is sine what? Sine 2x so our v is sine 2x multiplied by u prime, which is 6x, plus our u, it is what? 3x squared multiplied by our v prime is 2 cos 2x. Then we're going to expand here, so we're going to have what? 6x sine 2x plus 3 times 2, you're going to have 6x squared, then cos 2x. So what is common here? You factorize out 6x so that you remain with what? Sine 2x plus x cos 2x. So this is our final answer. Okay, so let's also look at the second example. Okay, so we have the second question here. Y is equal to the power, square root of x ln 2x. So we're going to separate them. We say let u be equal to 2 square root of x, then v be equal to into x. Okay, so u is equal to this one, we can change it so that we have 2x to the power 1 over 2, then v prime, this one we can differentiate, it is 1 over x. Okay, so what is going to be our u prime? Our proof. Okay, so when you multiply 2 times half, you are going to have 1, which is just going to remain with x. Then 1 over 2, you subtract 2 with 1, you are going to have negative 1 over 2. So now we can go back to our formula. Y prime is equal to vu prime plus uv prime. So y prime is equal to v. V is ln 2x multiplied by x to the power negative 1 over 2. Then plus, what is our u? Our u is 2x to the power half multiplied by v prime, it is 1 over x. So our u prime is going to be x to the power negative half in 2x plus, you have 2. Here we have x and there you have x. In between there's multiplication, but remember also there's a division there. So when you follow the laws of indices, you're going to remain with x to the power negative 1 over 2. In case you don't know where it is coming from, I've done this. Then x to the power half times 1 over x. 2, you're going to have x to the power half over x. When you have the same base, you maintain the base, and what do you do with the powers? You subtract the powers. So I'm going to have 1 over 2 minus 1, which is going to give you 2x to the power negative 1 over 2. That's where this negative half is coming from. So from here now you can factorize. What is common? You have x, you have x, you have negative half, negative half. So you can factorize out x to the power negative half. Then you remain with it in 2x plus 2. Okay. What are now going to do? This is a negative index. So you change it into positive. You're going to have 1 over. You're now going to have square root of x. Then in 2x plus 2. So that is our final answer. So the other thing that we are going to look at, we will look at the third question, which will be the last one. So we have the question here, the third one, y is equal to x to the power 3 cos 3x ln x. So if you have seen here, we have three products. So the first thing is we are going to make these two to be u. So let u be equal to x to the power 3 cos 3x, and then v is equal to in x. Okay, so that here we have these two products, there you have one product. So before we even solve the whole question, the first thing that we need to do is to differentiate this one using the same product rule so that we have one term. In short, we need to find the u prime. But how do we find the u prime when you have two products there? So we are again going to separate these two, of which you are going to have u is equal to x at the power 3, then v is going to be cos 3x. Okay, so now we can find the u prime here, which is going to be 3x to the power 2, and the v prime there, we're going to have negative sign, negative 3 sin 3x. Then we use the product rule. Okay, so u prime, we are finding this. We are going to have our u prime here, which is 3x squared, multiplied by v, which is cos 3x, then plus our v here, we have negative 3 sin 3x, multiplied by x to the power 3. So u prime is equal to 3x squared cos 3x. Here we are going to have minus x to the power 3 sine negative 3x to the power 3 sin 3x. So this is our u prime. Then we find the v prime here, which is going to be 1 over x. Then after now doing this, we are now going to solve our equation here. So we have y is equal to v u prime plus u v prime. So y prime is equal to, what is our v? Our v is here, ln x, multiplied by, what is our u prime? Our u prime is down here, which is 3x squared cos 3x minus 3x squared, or 3x to the power 3, then sine 3x, then plus. So these are like this. Plus, I'm going to take it down here. What is our u? Our u is this one, which is x to the power 3 cos what? 3x, multiplied by 1 over x. So our u prime is going to be, this ln x, you distribute it inside there, you're going to have 3x squared in x cos 3x minus 3x to the power 3 in x sine 3x, then plus, when you multiply this one, we're going to have x squared cos 3x. Okay, so y prime is equal to, what is common here? So we have x squared, x to the power 3x squared. So x squared is common. So here you remain with 3 in x cos 3x minus, you have 3 here, you've remained with the 1x there, in x sine 3x plus cos 3x, you cross brackets. Then y prime is equal to x squared, we use the square brackets. So if you have seen you have ln, so you can factorize 3 in x. Here you remain with cos 3x minus x sine 3x, then plus cos 3x. Okay, so our final answer is going to be y prime is equal to x to the power 2 is equal to cos 3x minus x sine 3x close, then you have 3 in x, then plus cos 3x. So this is going to be our final answer. Thank you so much for watching. We are now going to move further and look at another rule when this product rule fails to differentiate some equations, especially when we are going to start dealing now with the differential equations that are going to contain divisions. So watch out for the next video that we are going to publish very soon. Thank you.